that's what we're going to talk about. Well, what exactly are we talking about when we're burning LP or natural gas? We're talking about two different things. We're talking about direct gas fired and indirect gas fired heating. Direct gas, it's unique to the makeup air applications only, and it's because it's because of the application. It's because it's makeup air, and we'll kind of get into the weeds a little bit of why it's completely acceptable and even the anomalies that happen with, all right, we look at indirect gas fired, and there's even a shift. I know the state of California is very common for doing this. They've stepped away from direct gas fired because of the concern of byproducts of combustion being introduced into a space and the amount of CO and CO2. Where indirect gas fired, because of its efficiency, that gas is still being burned and it's still being vented out to the atmosphere, but much less efficient, and there's much higher levels of the CO and CO2. So interesting conversations. Direct gas fired, if you're looking at a gas heating option, definitely going to be the one that makes the most sense from an upfront cost, long-term cost, and overall operating stance. If you have access to gas, and again, your gas costs are less than what electricity would be. So the advantage with direct gas fired heating is there's no venting required. We still get this question from time to time. If a unit is installed inside, where does the venting go? It's literally a direct gas fired burner. So it's an open flame in the airstream. People forget that it's 100% outside air coming across that open flame burner. So technically 100% thermal efficiency, because you're taking 0-degree entering air and throwing it across an open flame burner. All of the heat loss associated with burning LP or natural gas is going directly into the airstream. Now, the concerns are what we'll talk about as far as the other things that are introduced into that airstream, but technically every single available BTU is where you want it, directly into the airstream to come into a space and get exhausted right back outside. Now, indirect, you do need venting outdoors. Most of these units are installed outdoors, so that's really not a big concern because it's just going to vent right out to atmosphere. But if it is an indoor installation, that's just considerations to have on the installer. You're going to need an intake pipe and a discharge pipe coming from that furnace to vent the flue gases out, and then at lower efficiency. So we're talking 92% efficient with direct gas fired heating versus 81% efficient. So that's typically what you're going to see in the industrial and commercial market. That efficiency is limited purposely because we don't want to condense inside that furnace. Condensate's not clean. It ends up basically eating away at heat exchangers, whether it's stainless or aluminum. And overall, you've got to worry about that water then when we're talking about higher efficiency applications. So 81% efficient, it would be considered a non-condensing furnace, so it can be mounted outdoors and you don't have to worry about heat tracing, bringing condensate back in and filtering it, neutralizing it. More installation costs, basically. Fun facts as well as far as efficiency goes on indirect gas-fired heat. You get more efficiency by basically putting more stuff in the airstream to reject more heat. Putting more stuff in the airstream basically just takes that efficiency and your gain of what you're burning gas at, and now it kind of marries it and takes it and transfers it over to your motor on your fan side, because you have more stuff typically to overcome on a higher efficient furnace too. So one other conversation piece on just why we limit efficiency on the indirect gas fired side and why the push toward higher efficiency, we don't really see it. 92% efficient on the direct gas fired side. If it's makeup air, you can typically get away with a direct gas fired application. We'll talk about why indirect is even in conversation. So require outside air for direct gas. The advantage with indirect, you can do a full recirculated option, standard on DOAS type applications where you can do literally no outside air and just recirculate 100% of that air across that indirect gas fired heat exchanger. Direct gas fired does require that outside air for bringing those byproducts of combustion down. Other advantage for direct gas fired heat, highest turn down in the industry, baked into the technology, 25-to-1 turn down. Now up to 16-to-1 turn down with indirect gas fired heat, but typically we see 4-to-1 as standard as far as pricing. So pricing on direct gas versus indirect gas, 4-to-1 typically versus 25-to-1 with direct gas fired. We'll talk about what that turn down capacity means. It's really tight temperature control is what it boils down to, but I got a couple slides that kind of discuss what that looks like further, especially with indirect gas fired. Now, the biggest advantage on the direct gas fired side, though, is definitely upfront cost and then overall operating cost. So depending on capacity requirement, how much airflow you're moving, 300 MBH and under, you're looking at still upfront 10% less typically for the direct gas fired equipment. And then as you increase that capacity requirement, you're going to see more of a gain on the direct gas fired side. Main reason being one single 6-inch burner section, 400,000 BTUs of capacity. To get more heat, you just simply keep growing 6-inch burner sections. We go all the way up to a 10-foot burner here at Greenheck, and that's where we can move 65,000 CFM of outdoor air and offer up to 7.2 million BTUs of heat. And regardless of where the electrification conversation goes there, I don't know where we're generating 7.2 million BTUs of available capacity in any other means right now, aside from burning natural gas or liquid propane. So that's another interesting part of as far as like more of the heavy industrial applications. I don't know how much of that you guys are doing work on, but just something to consider.